All right, everybody, it's your boy Mr. D back again for some more remote learning. We're going to work on a lab activity today together. So hopefully you've logged into Google Classroom at this point and uploaded this reading weather maps activity to Notability so you can follow along with me today using today's video and flip back and forth and work on the assignment as we go. First things first, we got to make sure we put our name on this assignment. So here we go. It is ya boy, Mr. D. I'm ready to go. Make sure your name's in there. Here's what we're going to do today. We're going to take a look at this data table here, and we're going to look at a national map that's set up for us, and we're going to think about a variety of things. We're going to apply our understanding here of high and low pressure systems and fronts, warm and cold fronts, and think about what's going on at these various locations weather-wise and what's going to happen in the future based upon this weather map that we're going to draw out today. So let's jump right in here. The first thing it tells us to do is label the air masses. We're gonna think about two different things here. Is the air warm or cold? We'll say warm or cool, warm or cold, and then we'll think about humidity. Is it dry or moist? Right. So we'll label two different kind of things with each air mass here. So right off the bat. We're going to go over here. This air mass we know is going to be, this is going to be a cool air mass. It's over the ocean, so it's probably got moist air. Cool and moist air mass there. Down here, Southern California, down there where Christian's from, we know we are going to have a warm air mass here, but also moist because remember it's coming in off the ocean. Now, down here, northern Mexico, South Texas, we're absolutely going to have another warm air mass here, but this time going to be dry. It's continental air. Up here over Canada, we're going to have a cold air mass, and this is going to be also dry because it's continental air. It's over a continent instead of a big giant body of water, so we're going to have cold, dry air. And there we go. One more air mass down here over the Gulf of Mexico. Classic spot for air masses to set up. We're going to have warm, moist air here as well. So there you go. We've got a variety of air masses on our map. We've got cool and cold, cold, cool, whatever you want to say. Cold, moist, and dry air out here over the Pacific off Southern California. We've got that warm, moist air, and all over the place, a variety of different air masses. That's going to become important here as we move forward. So we got step one done. Let's draw arrows around the highs and lows showing wind direction. Now, this is interesting. We learned this last time. I might make my line a little smaller here. But our wind direction, we know around a low pressure system, we know the wind is going to be swirling counterclockwise and inward. And you can kind of almost see the way those lines we're going to use for fronts in a minute, they're drawn kind of along the same shape, so our low pressure systems should look like this, with winds flowing inward and counterclockwise. The opposite is true. Well, let's get all of our low pressures done, right? We've got another one here with our, let's see, one more here, maybe like this. Our low pressures have winds flowing inward and upward, but also swirling counterclockwise. Now, high pressure is the opposite, right? High pressure, the winds are going to flow outward and to the right, away from the area of high pressure. So up there in Canada, it's going to look like that. And again, up here, this northerly high pressure just above the Great Lakes, we're going to have this outward and clockwise flow around our air mass, our pressure system. So low pressure, pause the video here if you want. Low pressure, you should have arrows flowing inward and swirling kind of counterclockwise. High pressure, outward and spinning to the right as those winds flow away from the high pressure. So we're clipping right along here. Hopefully you've paused at each little phase and finished it when I show you kind of roughly what your map should look like. But if we move on to step 3 here, on the lines extending from the lows, draw the correct front symbols. Here we go. So this is where we get to use our noggin a little bit, and we can think about these lines here and here. We can think about the fronts that would form here. So right off the bat, let's do this. I know that this front right here, I'm going to make my line a little heavier. I know that this right here must be a cold front. And I know that because we have a cold air mass here. And we know that if this whole thing is swirling like this, that this cold air must be moving this way. So let's get rid of all that scribbling I've been doing. And let's make a nice, clean, cold front that looks like this on our map. Remember, cold fronts are blue, and they should have blue triangles pointing in the direction that that air is moving. So if we have cold air overtaking warm, we've got a cold front, and there you have it. I know that because that right there is a cold air mass. And we know that that counterclockwise flow around the low pressure is going to do that. Now, the opposite is true here, because think about this. We just said this is a warm air mass right here, right? And if we have warm air here, and again, we have this counterclockwise flow around the low pressure system, I know that this line on the map has to be a warm front. And again, it's got to be flowing this way because of that counterclockwise kind of swirling flow around my low pressure system. So there you have that. And we have a couple more to do. Here we go again. If I know I have cold, dry air up here, and I know I've got counterclockwise flow like this around my low pressure, guess what? That means this must be my cold front right here, flowing around my low pressure there over the middle of the country. And then the opposite, then if I know I have a warm, dry air mass here and the whole thing's flowing this way because of that low pressure, that means that that line that they drew for me right here has got to be a warm front. Remember, both fronts will cause weather. They'll both cause precipitation. Cold fronts, though, tend to cause a little bit more severe, kind of heavy rain and the possibility of thunderstorms and tornadoes and things like that. We'll get to that in a couple weeks here. And then finally, again, here we go. We've got a cooler air mass up here that's flowing downward because of this low pressure system that's swirling in a counterclockwise direction. That tells me that this line must be my cold front. I'm going to draw it using my blue symbols here. And finally, we've already said that's a warm, moist air mass right there. It's got to be flowing like this because of that, the direction of the winds around the low pressure. So that means this guy right here must be a warm front, and that warm front is going to be drawn in red. We're going to use those half circles to point in the direction of the flow. It's really important that we pay close attention to what direction our half circles are pointing. That tells me that this front is moving this way. That's going to mean something for our weather at these various locations as we go today. So here we go. Here's another good spot to pause right here and think about, this is what your map should look like at this point. We've labeled our air masses. We've drawn our arrows for our air direction around each high and low pressure system. And now we even have our warm and cold fronts drawn in on the map. That is what your map should look like at this point. Real good spot to pause and make sure you're all caught up. Okay, welcome back after that little pause you just did to get caught up. See what I did there? And we're on to step 4. It says, using the circles on the map, place the correct air temperature at each city. Our current air temperatures are given right here. So we can just go through and plug those in. I'm going to go back to black here. Back in black. Yep, okay. A little AC/DC for you. And let's go San Francisco. San Francisco, they say, is 72 degrees. So I'm just going to put 72 degrees right here. Phoenix is 89. Oh, yeah, balmy. 89 degrees in Phoenix. Minneapolis is 58. In Minneapolis. Miami is 84. Let's go back here. Charlotte is 76. Let's see, 76. And Toronto is going to be 62 degrees. All right, here we go again. Good spot to pause. If you're looking to get caught up, we've got all of our temperatures now plugged in on the map. And here would be a good spot to pause to get yourself where you need to be. Okay, welcome back from that little pause you did there, and we're going to continue on. We are ripping right along on this activity. Our final thing is based on the locations of the fronts and air masses and the high and low pressure areas, we're going to describe the current weather at each city and predict how the weather is going to change in 24 hours. So here we go. If we look here, we've got San Francisco. It's 72 degrees. It's right along the coast. The front hasn't got there yet, but we know this cold front is moving in. Okay, the cold front is on its way to San Francisco. So that tells me something. We know cold fronts are associated with kind of severe, heavy rain and things like that. But if I look at current weather in San Francisco, there's some hints, right? We know that it's 50% cloud cover, so it's kind of a partly cloudy day. It's 72 degrees. It's kind of warm, southwest winds. And our barometric pressure is trending downward, which means it's dropping a little bit. But overall, we're doing okay. What's our dew point? Our dew point's 68. So it's, our air temperature is warmer than our dew point, which tells me it's probably not raining. So I'm going to say current weather, partly cloudy and warm. Weather prediction, here's what's going to happen. It's going to get cooler and it's going to rain in the next couple days. We know that because we know that cold front, based on the direction of those arrows we drew, those half triangles or those triangles tell us there's a cold front coming. We know cold fronts bring rain and colder air. So San Francisco, nice today, going to cool off and rain in the next couple. All right. Phoenix, we know if we look here, it's 89 degrees, 100% cloud cover. Interesting. We'll go to the map and see maybe why. The dew point is 89 and the air temperature is 89. That tells me it's raining. It's 100% cloudy and the dew point is the same as the air temperature. So if I go back here and look at Phoenix, look at that. Phoenix is right underneath or right at the edge of that cold front. Okay. So that tells me that current weather, it is rainy in Phoenix. But I know that we have this air mass here moving down over Phoenix as this low pressure swirls. So the future for Phoenix, after this rain is done, I know that Phoenix is going to be cooler, but also dry. We've got that dry continental air moving down over it. Let's focus on Minneapolis now. 0% cloud cover, sunny in Minneapolis. It's only 58 degrees. We got that cool, dry air over it. And if we look at dew points, oh yeah, that's dry air. 40-degree dew point, 58-degree air temperature. So let's think about this. Minneapolis is right here near high pressure, right? High pressure all around it. High pressure, we know means sunny, clear skies. So it is sunny and beautiful in Minneapolis. If we think about what's coming toward Minneapolis, well, in the next few days, I see a warm front that's moving this way. And we know warm fronts bring clouds and sometimes, light rain and warming temperatures. So let's go and let's do our current and future weather. Let's say Minneapolis is, right now it's cool and sunny. And it's going to be warm and cloudier in the future. Those are the weather conditions on their way to Minneapolis. All right, we're halfway there. Let's think about Miami. Miami right now, if I look, is right underneath that warm front. It's 84 degrees. There's a warm front right over the city. Let's check here. Look again. 100% cloud cover. No surprise there. They're right under a frontal system. Same dew point as air temperature. So that tells me it's raining. So here we go. We can say it's it's warm and raining, and we know that after that front passes by, we've got warm moist air here in the Gulf of Mexico that's going to move over Miami. There's a cold front coming too, but I think in the near future, it's going to just be kind of warm and cloudy as that warm front passes over. All right, Charlotte. Let's think about Charlotte here. Charlotte is currently 76 degrees. There's no fronts around it, but we know this warm front is coming eventually. So let's go and think about here. Let's see. Cloud cover, it's mostly cloudy in Charlotte because that low pressure is right nearby, right? Low pressure right nearby tells me it's probably cloudy. Might even be raining. Let's see. Not quite, but it's pretty heavy cloud, 68 degree dew point, 76 degree air temperature. So let's say this. Current weather in Charlotte is it's cloudy and cool. We know that warm front is coming. It's going to warm up, but that's also going to bring probably rain to Charlotte in the next couple days. Again, as this low pressure and as that warm front move in over Charlotte, it's going to warm up, but it's also going to be heavier clouds and rain due to that. Finally, let's think about Toronto. Toronto's up here with high pressure. We know high pressure means clear blue skies. It's got that cool dry air mass over it. Toronto's the place to be right now. Check this out, 62 degrees, totally sunny. There's not a cloud in the sky. Really low dew point, dry air. So let's say it is sunny and cool. If I look at Toronto, I see that really there's not a frontal system really anywhere near this thing. The low pressure is going to take a long time to get there if it's even heading that direction. We don't know that. So I'm going to say for Toronto, probably more of the same. They're in a good spot right there for a while. It's going to be cool and sunny in Toronto. That is the place to be if you like that nice, cool, dry weather. So there you have it. At this point, your data table should look a little something like that. This would be a good spot to pause and get that all filled in. Okay, welcome back after that pause to fill that in. And finally, you may have already paused to fill this in, but here's a great spot on your map, great look at your map, what your map should look like before you turn this assignment in. So again, I'll give you the opportunity to pause here to get caught up on this map. Okay, welcome back after that pause. We are done for today. I miss you guys. I'm going a little crazy here at home. Don't know if you could tell, but looking forward to getting back together here at some point. And I really appreciate all your hard work. You guys are doing great stuff out there with this remote learning. Please don't hesitate to reach out if you need any help or support on anything. I'm here for you guys. And let me know how I can help you. We will see you again next time. And if this